Oh, well, there we go. Hey, Algebra 2. Um, I'm gonna show you how to transform functions. So we've been looking at this in class. Uh, you will have a basic parent function. In this case, I'm gonna focus on the square root function. That's kind of the main function of our topic, although it fits for everything. And based on this equation, it tells you whether the function moves left or right or up or down, whether it stretches or compresses. And that's not so bad on a graph, and I'll show you that in a minute. It's transforming the table is what I really want to focus on. So let's get a few things established first. First of all, we want to talk about what is the parent function. So when you look at this function right here, g of x equals 2 square root of x plus 3 minus 1, there's one main function, one shape going on. Is it a quadratic, a cubic, a square root, a cube root? Is it a polynomial? Is it a log function, a rational function? There's a lot of functions we study in this class. And the key is what operation is happening. In this case, there is a square root right there. Okay. When I look at, this is page 2 of the packet we were working on that week of February before the 5-day weekend. So if we look at the previous page, you have a squared function. We call that a quadratic. Here it states the parent function. If you look at the next page, or the third page, there's right here a cube root function. You can see the root and the cube root. And so everything, if you look at the operation going on, you'll immediately be able to tell what the function is. And so in this case, the parent function we are studying, we are transforming, is a square root function. And so the first thing to do would be to establish a good table and a sketch. I just want to see what the parent function looks like. So our parent function is square root of x. That is the most basic square root function. It is what we are going to change to move around. Let me see if I can bring up a calculator here. Oh, good. You can see my screen. I may not have this anymore. Yeah, okay. So I just thought I'd show you for this function. I can go to the y equals menu. I can type in the square root of x. So I'm just typing in the basic parent function, not the transform function. And then if I go to the table, you'll notice for this function, it's a little strange. Everything, any negative input gives me an error. That's because I can't take the square root of a negative number, and you'll see that on the graph. So you can make any table you want to get a sketch, but there's one table that I'm going to use here, and that's it's easy to graph all whole numbers. So I see I've got 0, 0, 1, 1. If I keep scrolling down, I've got 4, 2. So if x is 4, y is 2. And let's see if I can find one more. Yeah, there we go. 9, 3. If x is 9, y is 3. You can keep going down. If x is 16, y is 4. But that's quite a bit further than my graph, so I'm just going to stick with those first 4 points, which you can see has already been set up for you on this worksheet. And so I'm going to go 0, 0, 1, 1, 4, 2, 9, 3. And the reason that's happening is because this is the square root function, so it's taking the input and square rooting it, and you get the output. The square root of 9 is 3, and so on. Okay, next I'm going to just identify the transformations, and I'm going to really, really focus on color. I want to take my time in this part right here, because if I can do this part well, then the rest of it is really straightforward. So I'm looking, anything outside the function is a y transformation. That too is a vertical dilation. That right there is a vertical dilation times 2, or by a factor of 2. This outside here, that is outside the square root, outside the function. That is a translation. We translate down 1. It says minus 1, we go down 1. And then anything inside, let's get a pretty color. Yeah. Anything inside the function will be an x transformation. We'll translate horizontally. We'll transform horizontally. In this case, it is translation. It will translate right 3. It's plus 3, so it goes right 3. But actually, things that are inside the function, things that transform x, are always opposite. So it's strange, but it'll actually translate this left 3. So those are my transformations, okay? A vertical dilation times 2, a translation left 3, and a translation down 1. What's cool now is that I'm going to graph this. I'm going to graph the original parent function using this table. So 0, 0, 1, 1, 4, 2, so right 4 up 2, 9, 3, so right 9 up 3. Square root functions look like a little hill. One of my students one year said they kind of look like the symbol itself. Not entirely, but I can see it. And then what's nice about using Smart Notebook here is I can kind of play at this transformation, just moving this around. So the points aren't going to move, but or I guess I can make them move here. So let's do this. I'm going to translate it left 3, so 1, 2, 3. I'm going to translate it down 1, so down 1. And then it said vertical dilation times 2. This will be a little hard to demonstrate, but I want to try and stretch that vertically. So it's not going to let me. So it would be like this, but taller. And I'm not going to be precise here, but something like that. Okay, that's what we're looking for. So in fact, what I'll do is I'll take this guy and I'll make it a little thin dotted line. And we'll see how close I am when I do the actual points. So let me move this guy back. Okay, the one that I just put there, that is left 3, down 1, and vertically stretched times 2-ish. But now what I'll do is I'll actually transform these points. And this is where my careful work before and my colors really, really help. So I'm looking at my x and y points, and I'm going to use the descriptions in the equation and in my transformations box. And so this one right here is the only x transformation. That's what's going to impact my x points. And so I'll take each of those x points, and I'm going to translate them left 3. I'll write that as x minus 3. I know the equation says x plus 3, but we know it's opposite. And so that means every single one of those x points just moves to the left 3. So I take that 0. Oh, neat. I have a little alarm. Stop. I just take that 0 and move it left 3. 0 minus 3 is negative 3. That's going to be my new starting x coordinate. 1 minus 3 is negative 2. 4 minus 3 is 1. 9 minus 3 is 6. What I'm doing down here is writing myself an instruction to take the parent function, the old x coordinates, and change them to the transform function, the new x coordinates. And I'll do the same thing for y. So with y, it looks a little more complicated, but it's really not. I am going to use just the y's and transform the y. So what's happening here is I am multiplying by 2 and subtracting 1. That is a multiplication. That's a minus 1. I'm going to ignore this x plus 3 because I'm only dealing with the y's. And so I'll say 2y minus 1. And I'll take each of these points, I'll multiply it by 2 and then subtract 1. A lot of this, we don't get really complicated numbers, so you can probably do it in your head. I'll show you on the calculator how I would do it. I'd say 2y, and I'm going to do my first point right now, so 2 times 0. Oh, I love it. My head is right on the calculator. That's really helpful. 2 times 0 minus 1, and I get negative 1. So my first coordinate is negative 1. I can keep doing this. I'll go for the next one, 2 times 1 minus 1. I am doing 2 times my y coordinate, and then I minus 1, and I get positive 1. And let me just continue that on the calculator here so you can see all of them. 2 times 2, 2 times 2 minus 1. Let's actually put the 2 in. And 2 times 3 minus 1. All right. And so I get negative 1, 1, 3, 5. Negative 1, 1, 3, 5. Now I can plot these points, and I will see what the actual transform function looks like. So negative 3 comma negative 1 goes here. Negative 2 positive 1. Negative 2 positive 1 goes here. 1, 3, 1, 3 goes here. Oops, not there. Positive 1, 3. My bad. Positive 1, 3. And 6, 5. 1, 2, 3, 4, 5, 6, 4, 5. Hey, hey. My little guess of a graph is not bad. Look at me smiling right now like a dork. I like that. That was good. Okay, I'm looking at the time. I got about 5 minutes left in this video. I feel kind of embarrassed that my head was covered for those coordinate points, but oh well. So I'm going to scroll up to this one. I'm going to go pretty quickly through writing the equation so I can get straight to the transformations. One thing I am going to do, since this is the same parent function, is I'm just going to copy and paste this. This graph is not going to be different on this one. Oops, if I can copy and paste it. Come on, bud. There we go. So it's still 0, 0, 1, 1, 4, 2, 9, 3. Okay. And so for the parent function, well, I have the parent function. For the transform function, what I'll do is I'll start by writing I'll leave a gap and then write a square root and then put an X and then leave some extra space. And that's where I'll put all my transformations. So it says vertical dilation by a factor of 1/2. That's what goes in front. There's my vertical dilation. It says up 3, right 2. Right 2 feels like it should be plus 2 inside, but actually it's minus 2. That right 2, that is an X change. That goes inside the function. Up 2, that's, up 3, that's a vertical transformation, a Y transformation, which means it goes outside the function and it's normal. That's what your equation should look like. And so now I can use those to transform my parent function points into my transformed function points. So when it says translate right 2, this makes me want to put x minus 2 right there, but that is not how it's transformed. It's opposite. And so it should actually be x plus 2, translates right 2. And so all these points I'll add to. 0 plus 2 is 2. Hey, cool, it matches. 1 plus 2 is 3. 4 plus 2 is 6. 9 plus 2 is 11. And then for my Y transformations, I'm going to do these two things. So I do 1/2 Y plus 3. What I'm looking at is that 1/2 is a multiplication. That's 1/2 times the function. And then plus 3. So 1/2 times the function plus 3. So I take each of these points, I'm going to multiply them by 1/2 and add 3 to them. And so let's look at this. I'll do it in the calculator again. So I'm going to go 1/2 parentheses, and my first point is 0. So 1/2 times 0 plus 3. And I'll just keep repeating that with each of the points that I have there, with 1, with 2, 1/2 times 2 plus 3, and with 3, 1/2 times 3 plus 3. And that gives me all my new outputs: 3, 3.5, 4, 4.5. So let's get this here. Oh yeah. So 3, and hey, that matched. Yay. 3.5, 4, 4.5. I forgot to do something down below. That equation transformed in those points. Look how much prettier that is. Got to do that down here. This right here were the instructions to transform into these new outputs, these new Y coordinates. Okay, so now I should be able to graph these, and I should see my transformation, and I should not run out of time. So 2, 3, so right 2, up 3, right there. 3, 3.5, right 3, up 1, 2, 3.5. 6, 4, 3, 4, 5, 6, 2, 3, 4. And 11, 4.5. That's going to be a little off the graph. That's okay. 4.5. Since it was vertically dilated times 1/2, that's a compression. It kind of squished it down, so it's a less steep hill. So that's how you transform tables, which then makes it very easy to transform a function on the graph once you can plot those points. So thanks for your attention. Good luck.